We often use the word constraint in our daily life. So what is a constraint? For example, if you have a water, okay, so the water has a property that it will flow always, okay, it cannot be given a definite shape. It will take the shape of the container in which it is kept. For example, if you have a glass and in that glass if you pour the water, then the water will take the shape of this glass. Okay, now the motion of the water is constrained over here. That means it cannot flow through the walls of this glass, right? So this is a example of constraint. Another example can be that of the animal trapped in a cage. For example, if you have a cage like this, and in this cage an animal is trapped, okay, maybe a tiger, okay, like this. So the animal is constrained within the four walls or the four boundaries of this cage, okay, and it is a constraint imposed upon it. Okay, so now in physics we will see some examples based on constraints. For example, one thing is that if I have a wedge like this and if I keep a box on it, okay, on the surface of the wedge, then the box has a mass m. Suppose when it is on the wedge, it always be on this particular surface, so its motion is along this direction always, okay, or it can go along the upward direction, but it can never go inside the wedge. Okay, so this is a constraint imposed over here. There can be another example. For example, if you have a straight wire, okay, and a bead is there, that means the wire is going through this bead. So the bead's motion is constrained in this direction or this direction, that is always along the wire. Okay, we can never leave the wire. So wherever the wire goes, wherever the wire turns, in the same way the bead will turn. Okay, then there is another example of a pulley. Okay, so if you have a pulley like this and if you pass over a string on it which is attached to a mass, let's say this is mass m1 and there is another mass m2 which is attached to the another end of the string, right? So then this is also a constraint. For example, if I take this as length x1, okay, or you can say I am choosing my coordinate system, let's say this is O, origin. So the coordinate of this particular mass m1 m2 is x2, and for this particular m1 it is x1. Then x1 plus x2 will always be equal to L, that is the length of the string. Of course, I am assuming that the string is inextensible string. That means you cannot extend it beyond its original length, or you cannot compress it beyond the original length. So this is a constraint on the system, right? So another example can be ball is there and ball is kept on a ground, and let's say the upward direction we are denoting as a z axis. Okay, then the ball's position will always be such that it is greater than or equal to 0. So it can never be gone inside the ground, it can never take the z values to be negative, it will always be positive. So this is one example. Another example can be again, if I have a closed container like this, and in this closed container I inject a gas, then the molecules of gas will be confined inside this container. Okay, so they will do motion, random motion inside the container. So the molecules of the gas are constrained by these four walls of the container, they will never go out. Okay, so these are the example of constraints. In our next session we will see how to write the expression for constraints.